Okay, this video is going to be about implicit differentiation from chapter 2.5. There are certain reasons why you would need to use implicit differentiation. The first reason is if you can't solve for y equals f of x explicitly, and the second reason is if solving for y equals f of x would be difficult. Here are some steps to follow when you are using implicit differentiation. The first step is to always differentiate both sides of the equation with respect to x, and it's always with respect to x. The second step would be to move all the terms involving dy over dx to the left side of the equation, and then move all the remaining terms to the right side. The third step would be to factor out dy over dx out of the left side of the equation, and then solve. Okay, so here's our first example. When asked to use you would have to use implicit differentiation here because it'd just be too difficult to solve for y explicitly. So the first step is to differentiate both sides of the equation. So you do d over dx, x squared plus y cubed plus x cubed plus y squared equals, and then also differentiate this side. And then you just find the derivative of each side. So this is 2x plus 3y squared y prime plus 3x squared plus 2y y prime, and the derivative of a constant is just 0. So then you move all the terms involving y prime to the left side and everything else to the right side. So that would leave you with 3y squared y prime plus 2y y prime equals negative, because you move everything to the other side, negative 2x minus 3x squared, and then you factor out y prime from the left side. So y prime equals 3y squared plus, sorry, y prime doesn't equal that, y prime times 3y squared plus 2y equals negative 2x minus 3x squared. Now all that's left to do is to divide this over to the other side and solve for y prime. So y prime equals negative 2x minus 3x squared over 3y squared plus 2y. Okay, so in some cases we might be asked to find the second derivative. So in order to find the second derivative, you'd need to find the first derivative first, obviously. So we're going to start off the exact same way. So d over dx, x squared plus 4y squared equals d over dx of 1. So this is going to leave us with 2x plus 8y y prime equals 0. And moving everything with y prime to the left and everything else to the right is 8y y prime equals negative 2x. So solving for y prime is equal to negative 2x over 8y. So y prime equals negative x over 4y. So this right here is our first derivative. And now we're going to solve for the second derivative. Okay, so to solve for the second derivative, we're going to come back up to this, this part right here, and we're going to simplify that. So we're going to say x plus 4y prime is equal to 0. And you're just going to find the derivative of this. So 1 plus, now we have the product rule that we have to use to solve this term, to find the derivative of that term. So it's going to be the second, or your second term times the derivative of the first, times the derivative of the first, 4y prime, plus the first times the derivative of the second. That's going to equal 0. So we're left with 1 plus 4y prime squared plus 4y double prime is equal to 0. So we're going to move everything with y double prime to the left and everything without it to the right. So it's going to be 4y double prime equals negative 1 minus 4y prime squared. Solving for y double prime is y double prime is equal to negative 1 minus 4y prime squared over 4y. Now notice how we have y prime right here. We just solved for y prime right here. So we can just substitute this in for y prime. So we're going to say y prime is equal to negative 1 minus 4 times negative x over 4y squared all over 4y. So I need some more room. So now we're just going to distribute this 4. So y double prime equals negative 1 minus 4x squared over 64y squared. That's not 64. 64y squared. All over 4y. So y double prime equals negative 1 minus x squared, just simplifying this term, x squared over 4y squared all over 4y. And then we're going to want to find a common denominator for this up here. So we're going to multiply this by 4y squared over 4y squared. So y double prime is equal to negative 4y squared minus x squared over 16y cubed. And we're going to factor out a negative up here, so y double prime is equal to negative 4y squared plus x negative 4y squared plus x squared all over 16y cubed. And then notice how this right here, 4y squared plus x squared, is the same thing as up here. So x squared plus 4y squared is equal to 1. So we can just substitute that in down here. So we can say y double prime is equal to negative 1 over 16y cubed. And we can't simplify it anymore, so that is our second derivative. And that's the end of this video. Thank you for watching.